Dear students, today I am solving the CBSE sample paper 2024-25 like previous year's sample paper because your pre-board examinations are very near. So please go through these solutions of the last year paper, sample paper, also this year sample paper I am giving you. And if at any point you find difficulty or doubt, so repeat the video and watch it again and again, and still you are not clear, then feel free, if you are not clear, then feel free to write or in the comment box that sir, this is my problem, I am not understanding it. So I will try to solve your problem again. So हाँ, एक बात जरूर है, अगर चैनल को अभी तक सब्सक्राइब नहीं किया या पहली बार देख रहे हैं तो सब्सक्राइब कर लें। उसका ये फायदा होगा आपको कि आप पिछले जो वीडियोस हैं उनको भी देख पाएंगे और फोर्थ कमिंग वीडियोस तो जो है वो आपको मिलते ही रहेंगे फटाफट। और चूंकि आप इसको समझ रहे हैं, देख रहे हैं, तो आपके जो दूसरे फ्रेंड्स हैं उनको भी शेयर कर लें, क्योंकि आपको ये मत सोचें कि उसके नंबर ज़्यादा आ जाएंगे, ऐसा कभी नहीं होता है। जब आप किसी को कोई चीज़ बताते हैं, देते हैं, तो आपके नंबर उससे ज़्यादा ही आते हैं, कम नहीं आएंगे। और आप जितना ज़्यादा किसी को समझाएंगे, बताएंगे, शेयर करेंगे, तो आपके नंबर उतने ही ज़्यादा बढ़ेंगे, बिकॉज योर कॉन्सेप्ट विल बी वेरी क्लियर। आप जब भी इसको देखें, ऑब्जर्व करें, तो आपको समझने की कोशिश करें, तो जब दूसरे को समझाएंगे तो फिर आपको और ज़्यादा क्लैरिटी आएगी। तो अपने फ्रेंड्स को ज़रूर समझाएं और उनके साथ शेयर भी करें, तो उससे आपके और कॉन्फिडेंस होगा, आपकी और कमांड होगी। तो इस तरह से आप करें। तो आगे हम अगला क्वेश्चन करते हैं और शुरू करते हैं इस क्वेश्चन पेपर को सॉल्व करके। और आप आराम से जो है इस जब भी तैयारी आप करें तो बिल्कुल रेगुलर रखें और पढ़ाई को नियमित रखें। ये नहीं कि किसी दिन 4 घंटे पढ़ लिया, एक दिन आप आराम से मजे कर रहे हैं, ऐसा नहीं है। ये थोड़ा लिमिटेड टाइम आपका रह गया है, तो बिल्कुल मतलब कंसिस्टेंसी इन एफर्ट्स जो है दैट इज वेरी इंपॉर्टेंट, ये ध्यान रखें आप। एंड स्लो एंड स्टडी विंस द रेस। तो आप जितना ज़्यादा स्टडीली काम करेंगे तो आपके मंजिल तक पहुंचने के चांसेस उतने ही ज़्यादा हो जाते हैं। ऑल द बेस्ट। So the first question is a uniform electric field pointing in positive x direction exists in a region. Let A be the origin, B be the point on the x-axis at a distance of x is equal to +1 centimeter, and C be the point on the y-axis at y equals to +1 centimeter. Then the potential at points A, B and C satisfy option A, VA is less than VB, यानी potential A at A is less than potential at B. The B option is VA is greater than VB, यानी potential at A is greater than potential at B. Then C, VA is less than VC, and D, VA is greater than VC. We know that the electric potential is related with E by minus E dot dl. That means this potential difference is minus E dot dl. Means the electric field is this direction, and this is the point A, and the B point is at a distance of 1 centimeter this side, and C point is +1 centimeter this side. So here dV equals to minus E dot dl means the potential goes on decreasing along the direction of electric field. As we move along the electric field, then potential starts falling or it decreases. Means VB minus VA is negative. That means VE minus VA is less than 0. So VB is less than VA. That implies VA is greater than VB. Similarly, here this dot, the angle between the electric field and this DL is 90 degree. So for CA, dV equals to 0. So that means VC minus VA is equal to 0. So VC equals to VA. So the options A, VA is less than VB is incorrect, and the second option VA is greater than VB is correct. So the correct answer is B. And again the next two options are also incorrect. So the correct answer is B. Question number 2. A conducting wire connects two charged conducting spheres of radius R1 and R2 such that they attain equilibrium with respect to each other. The distance of separation between the two spheres is very large as compared to either of their radii. The ratio of the magnitudes of the electric fields at surfaces of the spheres of radii R1 and R2 is A. R1 upon R2, B. R2 upon R1, C. R2 square upon R1 square, and D. R1 square upon R2 square. So the conducting sphere, this is R1 and this is R2. They are separated by a long distance as compared to their radii. So initially they must be having some different charges, but when the equilibrium will establish, so that time their charges is suppose Q1 and here it is Q2. It is not necessary that in equilibrium the charges will be same. What is the condition for the equilibrium? That their potential must be same. Therefore, no transfer of charge will take place after that. So here we will have V1 equals to KQ1 upon R1 and V2 equals to KQ2 upon R2. Initially the potential were different and the charge was also different. But when the equilibrium is established, the potential here is KQ1 by R1 and the potential here is KQ2 by R2. But in equilibrium, V1 is equal to V2. So that implies KQ1 upon R1 equals to KQ2 upon R2. That implies R1 upon R2 equals to Q1 upon Q2. R1 upon R2 is equal to K will cancel out. So Q1 upon Q2 equal to R11 by R2. This condition is there. Now we have to find the ratio of the electric fields. So E1 will be equal to K Q1 upon R1 square and E2 will be equal to K Q2 upon R2 square. K Q1 upon R1 square and K Q2 upon R2 square. So the ratio E1 upon E2 will be K will cancel out, or you can say K Q1 upon R1 square upon K Q2 upon R2 square. K will cancel out, so it will be Q1 upon Q2 and this will get reciprocal. Then R2 square upon R1 square. Q1 upon Q2 is equal to R1 by R2 into R2 square by R1 square. So they will square will cancel out. So you will get simply R2 by R1. So we have E1 upon E2 equals to R2 by R1, and the correct option is B. A is R1 by R2, that is not correct. B is R2 by R1, that is absolutely correct. C is R2 square by R1, so there is no this, and D is R1 square upon R2, that is also not there. एक बार फिर से देखें, इसका इनिशियली चार्ज सपोज Q1 डैश रहा होगा, तो उस समय जो पोटेंशियल रहा होगा वो रहा होगा V1 जो है K Q1 डैश अपॉन R1, और दूसरे का जो है उस समय अगर मान लीजिए चार्ज Q2 डैश था तो उस समय V2 रहा होगा K Q2 डैश बाई R2। अब ये दोनों डिफरेंट हैं। जब डिफरेंट पोटेंशियल वाले दो बॉडीज को हम कनेक्ट करते हैं या कंडक्ट कराते हैं, तो देन चार्ज स्टार्ट्स फ्लोइंग, और ये कब तक फ्लो करेगा? टिल द इक्विलिब्रियम इज स्टेब्लिश। सो दैट्स व्हाई वी सपोज दैट एट इक्विलिब्रियम this conductor is having charge Q1 and this conductor is having charge Q2, and these are the spheres. So at that time the potential on the first will be K Q1 by R1 and on the second it will be K Q2 by R2, but since they are in equilibrium, so their potential will be same. So V1 is equal to V2, so this gives you a condition K Q1 by R1 is equal to K Q2 by R2. That means R1 by R2 is equal to Q1 by Q2. Now we have to find the ratio of the electric fields. So E1 is equal to K Q1 by R1 square at this position, and here it will be K Q2 by R2 square. So the ratio will be E1 by E2 is equal to K Q1 by R1 square upon K Q2 upon R2 square. K will cancel out, so it will be Q1 by Q2, and this will get reciprocal. So that is R2 square upon R1 square. That is Q1 by Q2 can replace R1 by R2, and then they will cancel out, and ultimately we will get R2 by R1. So that means E1 upon E2 is equal to R2 by R1. So the correct option is B. So question number 3. A long straight wire of circular cross section of radius A carries a steady current I. The current is uniformly distributed across its cross section. The ratio of magnitudes of the magnetic fields at a point A by 2 above the surface of the wire to that of a point A by 2 below its surface is A 4:1, B 1:1, C 4:3, and D 3:4. So here a long straight wire, I'm just making it a broader because we have to consider this is the A radius. So this is some point P which is at A by 2. That means from the center it will be 3A by 2. This distance will be 3A by 2. And another point is Q, that is A by 2, this way. And a current I, suppose, is flowing through this. For a straight current carrying conductor, B is given by mu naught I upon 2 pi R. And here the current is uniformly distributed, so the current density J is equal to current upon area of cross section, that is pi A square. So in the first case at P, B will be equal to mu naught I upon 2 pi, and R is 3A by 2. So this is 3A by 2. 2 will cancel out. So we have got B, we call it BP, is much better. So mu naught I upon 3 pi A. Now we have to find at Q. So BQ will be equal to mu naught. Now this current will be not this much. This time the current will be through this cross section. So I dash will be equal to J times pi A by 2 square, because I equal to J into area of cross section. So here the area of cross section is A by 2 square. The value of J is I upon pi A square, into pi a square by 4. So pi square cancelled. So the current comes I by 4. So here will be I by 4 upon 2 pi r, and r is a by 2. So this 2 cancelled again. So here we get mu naught I upon 4 pi a. This is BQ. Now the ratio BP upon BQ. So BP upon BQ will be equals to mu naught I upon 3 pi a divided by mu naught I upon 4 pi a. This mu naught I will cancel out, pi will also cancel out, a will also cancel out, and this will be, this 4 comes, or you can write it mu naught I upon mu naught I, and here you get 4 pi a upon 3 pi a. This will cancel out, this will cancel out, so you get simply 4 by 3. So the ratio of BQ is 4:3. So the A part is 4:1, B is 1:1, C is 4:3. So the correct option is C, and the D is 3:4. That is not correct. So once again, this is the conductor, and current I is passing through the cross section, and it is distributed uniformly across this cross section. So magnetic induction or magnetic field due to a straight current carrying conductor is always given by mu naught I upon 2 pi r. For a straight current carrying conductor, infinitely long, it is infinitely long. So at point P, the distance is a by 2 above the surface. That means from the center it is 3a by 2, a by 2 plus a, 3a by 2. So here will be mu naught I upon 2 pi r means 3a by 2. This 2 cancel out, you will get mu naught I upon 3 pi a. This is the BP. Now for Q, the current will not be I, but the current will be across this small cross section. So for that we have to first find out the current density J equals to current per unit area of cross section. So I upon pi a square. So I dash will be equal to J into area of the cross section, pi a by 2 square. So J will be replaced by I upon pi a square, and then it will be pi a square by 4. So pi a square cancel, that's I by 4. So here BQ will be equal to mu naught I by 4 upon 2 pi a by 2, because radius is r is distance is a by 2. So this 2 cancel again. It is mu naught I, and this is pi a, and this 4 comes down. So it is 4 pi a. Now the ratio BP upon BQ will be mu naught I upon 3 pi a divided mu naught I upon 4 pi a. So mu naught I upon mu naught I, then this will just reverse, reciprocal. So this 4 pi a come in the numerator, and 3 pi a goes to the denominator. So mu naught I cancelled out, pi a cancel out, so you get 4 by 3. So the BP ratio BQ is 4:3, and the correct option is C. Question number 4. The diffraction effect can be observed in A. Sound waves only, B. Light waves only, C. Ultrasonic waves only, and D. Sound waves as well as light waves. You might have played hide and seek game in your childhood, और आजकल तो आप मम्मी पापा के साथ लुका छुपी करते हैं कभी कभी, हालांकि करना नहीं। लुका छुपी कैसे कि बेटा टेस्ट के पेपर मिल गए, नहीं पापा नहीं मम्मी, जबकि क्या होता है जब वॉशिंग मशीन में आपकी यूनिफॉर्म धोने के डालते हैं और मम्मी जब पॉकेट चेक करती है तो उसमें नंबर कॉपी जो है आपका मिल गया होता है टेस्ट पेपर। तो दैट मीन्स ये करना नहीं है, नंबर कम आ जाते हैं तो उसका सॉल्यूशन करना है, ढूंढना है कमी कहाँ रह गई, उसको देखना है ना। और जब तक वो कमी दूर नहीं हो जाए रुकना नहीं है, एफर्ट्स में कंटिन्यू रखनी है और कोशिश पूरी करनी है, क्योंकि कोशिश करने वालों की कभी हार नहीं होती। तो ये कहने का मतलब है कि आपको there is no escape and there is no option for the success rather than hard work, regular and hard work in smart work. ये बहुत जरूरी है. So here hide and seek, during hide and seek you might have observed that if a person is hiding behind the wall and he or she is not visible to you, but the moment he or she whispers or sneezes or makes some cough, खांसी करता है या कुछ और साउंड प्रोड्यूस हो जाती है वहां उसके एंड से, then immediately it is audible to you and you just make him out, because this time the sound is diffracted or diffracting. That means light was not able to diffract, but sound was prominent and was diffracted. So diffraction depends on the wavelength. If the wavelength is large, so the more diffraction will be there, and if the wavelength is small, then less diffraction will be there. In case of light, you have defined the diffraction as the bending waves. ये देखिए, you just see here, see the light is coming from this way and ultimately, but it starts from here. तो यहां से फिर यहां तक चलेगी, डार्क प्लेस यहां आ रहा है, यहां हल्का आ रहा है, that means light is bending. Similarly, it is the spreading of wave. ये सीधा जाना चाहिए था, but ये क्या है, ऐसे आ रहा है, तो it spreads about an opening. So diffraction is the bending of wave round about an edge or spreading around an opening. And sound is also diffracted, as you have seen in your hide and seek. So there, the option A, sound moves only, this is not correct. B, light waves only, this is also not correct. Ultrasonic waves only, not correct, because sound is diffracting, light is also diffracting, so alone is not there. So D option, the sound waves as well as light wave. Ultrasonic are also sound waves. So you can say D is the correct option. So sound, in case of the sound, the diffraction is more prominent. जैसे कई बार आप देखें कार आ रही है अगल बगल से कहीं से, आपके नोट दिखाई नहीं दे रहा, लेकिन उसकी साउंड देखिए, अभी आपको देखिए हॉर्न सुनाई दे रहा है, लेकिन यहाँ कहाँ विजिबल है, बट स्टिल इट डिफ्रैक्ट्स लार्ज, it diffracts more than the light. So here the option sound waves as well as light waves, so option D is correct. Question number 5. A capacitor consists of two parallel plates with an area of cross section of 0.001 meter square, separated by a distance of 0.0001 meter. If the voltage across the plates varies at the rate of 10⁸ volt per second, then the value of the displacement current through the capacitor is A, 8.85 into 10⁻³ ampere, B, 8.85 into 10⁻⁴ ampere, C, 7.85 into 10⁻³ ampere, and D, 9.85 into 10⁻³ ampere. So here the answer, so the area is given 0.001 meter square, and this separation D is given by 0.0001 meter, and the dV by dt is given you 10⁸ volt per second. So the displacement current you have to find. So displacement current is given by C dV by dt. Here we have the dV by dt, but we don't have C, so we can find C equals to epsilon naught A by T. A is given to you, D is given to you, epsilon naught is also given in your table in the क्वेश्चन पेपर और याद भी रहता है। Therefore, I displacement equals to epsilon naught A upon T into dV by dt. That means 8.85 into 10 to the power minus 12 into A. A is, you can say this is 10 to the power minus 3 meter square, and this is equals to 10 to the power minus 4 meter. So here it is 10 to the power minus 3 upon D 10 to the power minus 4 into dV by dt is 10 raised to power 8. ID is CV by D, C dV by dt. C is epsilon naught A by D. Now putting the value of epsilon naught, this ID will go to epsilon naught A upon D into dV by dt. Putting the values, displacement current will be epsilon naught is 8.85 into 10 minus 12. A is 10 to the power minus 3 and D is 10 to the power minus 4 and dV by dt is 10 to the power 8. So this is minus 4 and plus 8. This goes up to plus 8, so this 12 will cancel out. And here simply we get 8.85 into 10 to the power minus 3 ampere. So the option A, 8.85 into 10 to the minus 3 ampere is absolutely correct. B is 8.85 into 10 to the minus 4, that is not possible. C is 7.85, again not possible. 9.85 is again not possible. So the correct answer is A, fifth A.